Okay, hi guys. So in this lecture we'll be starting off with Beckmann rearrangement. Okay, so let me first put down the heading. So we'll be starting off with Beckmann rearrangement. Okay, so in this, let's suppose we have a compound like this, which is called ketoxime. Okay, what will happen is when we react this compound with H2SO4, or it can be HCl or TSCl or PCl5, or it can be SO2 gas as well. So what would be the compound which will be forming? So we'll get something like this as the product. Okay, and we can write it as that ketoxime convert into 2-degree amine in presence of acid and catalyst, and this is known as Beckmann rearrangement. So Beckmann rearrangement is nothing but ketoxime converting into 2-degree amine in presence of acid and catalyst. Okay, so let's actually have a look at the mechanism to understand this reaction better and appreciate the product formation. So we have this as the reagent or substrate rather. Okay, R1 here and OH here. So what will happen in acidic medium first is this OH as always will attack first on the H plus, and we'll get something like this compound as the intermediate. Okay, now next step what will happen is this oxygen molecule, or rather water molecule, will be removing itself from the nitrogen atom, and rearrangement will take place in which, let's say, R1 had more migratory aptitude than R, so R1 would instead be migrating to nitrogen atom to fulfill the space which is formed as the oxygen molecule is leaving the nitrogen bond. Okay, so this would be the RDS of this reaction. So we'll be getting something like RC plus, and actually this is not another C, this is directly bonded with double bond N. Okay, and we'll have R1 rearranged here. Now what will happen is, again on this carbocation, water molecule will act, and as a result we will be having something like this. Okay, so this will undergo tautomerism. Okay, as a result we'll be getting a amide, or rather a 2-degree amide. Okay, so I think in here I wrote amine, so just pardon me, this is amide. Okay, so how does the rearrangement actually happening? Rearrangement is actually different from what we saw from the pinacolone rearrangement. Okay, so rearrangement is different from rearrangement in the case of pinacolone rearrangement. Okay, so we write rearrangement is different from pinacolone rearrangement, as in, so in pinacolone rearrangement we saw that actually the migrating group would occupy, means let's suppose this is the place from which the living group is detaching its bond from the carbon atom, and R1, which is migrating towards C or carbocation, would be positioned in such a way that it is opposite to the living group. Okay, so in that case, if the living group was coming out of the plane, attached out of the plane, the R1 would be migrated and attached to carbon atom beneath the plane. Okay, or in other words, you can say that it was inversion of configuration. Okay, so, but in this case, what is actually happening is we have this product, right? So in this case, R1 was migrating to the nitrogen atom, in which O plus was leaving the nitrogen atom. So what this R1 will do is R1 will be entering the nitrogen atom in its anti-bonding. Okay, we will be discussing what is anti-bonding and other types in our inorganic chemistry lectures, but for this scenario, just remember that R1 would be attacking the anti-bonding orbital of nitrogen atom, hence retention of configuration what will take place, not inversion of configuration. Okay, hence retention of configuration will take place. We'll see this point in the characteristics as well. So let me write down the characteristics. So we have something like, so the migration is the redetermining step. Okay, so migration is redetermining step. Second point would be concentrated H2SO4 is preferred over dilute H2SO4 in Beckmann rearrangement, because in dilute H2SO4 the amide formed hence as the product will undergo hydrolysis. Okay, if we see the product is something like amide, where we have something like this structure. Okay, now if we actually use dilute H2SO4, what will happen is it will act as a acid here. Okay, and will donate its H plus. But in case of concentrated H2SO4, what will happen is the concentrated H2SO4 will act as a stronger acid than the NH group, hence the NH group or the amide structure will retain itself as the product in the more acidic conditions, hence concentrated H2SO4 would be used. Okay, let me write it down formally. So we have concentrated H2SO4 is preferred over dilute H2SO4 in Beckmann rearrangement. Okay, in Beckmann rearrangement because in dilute H2SO4 amide will undergo hydrolysis. Okay, let's look at the third point, where we have the Beckmann rearrangement doesn't take place in basic medium. Okay, why does it not take place in basic medium? Because in the first step only, the ketoxime, the OH on the ketoxime actually reacts with H plus from the acidic medium, and then the reaction will go in the forward direction. Okay, but if it's initially only placed in the basic medium, while ketoxime is itself a kind of a base, then no reaction will take place. Okay, and the 2-degree amide will not be formed. Okay, so Beckmann rearrangement does not take place in basic medium. Okay, next point would be that the anti group will migrate in this direction. Okay, so the anti group will migrate in this reaction. Okay. So what do we mean by the anti group will be migrating in this direction? So as we seen in the previous example which I showed you, that how the rearrangement is different from the pinnacle-pinnacle rearrangement. In the pinnacle-pinnacle rearrangement, we actually saw the inversion of the configuration, in which the compound or the group which was having more migratory aptitude would be moving, right? But in this type of, or in the Beckmann rearrangement, the compound which will be moving, which will be attacking the anti-bonding should be anti, right? So in the pinnacle-pinnacle rearrangement, the compound or the leaving group does not attack on the anti-bonding orbital of the carbon atom, but in this case the moving group would be attacking in the anti-bonding orbital of the nitrogen atom. Okay, and for the leaving group to attach at the anti-bonding or attack on the anti-bonding position, it should be anti to the leaving group. Okay, so I'll explain you with the example. So suppose we had something like this. Okay, and OH was actually moving in this case as a water molecule, and this was the anti-orbital for the OH attached. Okay, this was the bonding orbital between N and O, and this is the anti-bonding. Hence, the compound which is in anti position to the leaving group would be migrating. Okay, and as a result, retention of the configuration will also take place. Okay, similarly, if I show this example wherein we have something like this, R1, R2, R3, and we have carbon, and here I have R2, and suppose in this case we have OH here, then the anti-bonding orbital for the bond between O and N would be this. Hence, which of the two groups would be attacking on the anti-bonding? Obviously this group, because this is also anti to the leaving group, so this would be attacking on this anti-bonding orbital. Again the retention will take place. As a result, we will get something like positive charge here, and again R1, R2 and R3 here. Okay, so it will attack in the anti-bonding position, and hence the retention of the configuration will take place. Okay, while in pinnacle rearrangement, more migratory aptitude was seen. In this case, the migratory aptitude is defined as the compound which is anti to the leaving group, that would be migrating to the nitrogen atom. Okay, so basically this is a twist in the definition of migratory aptitude. The original migratory aptitude definition still remains valid, that more the migratory aptitude means more there is plus M or plus I or plus H group attached in the group which is migrating. Okay, and in this case the migrating aptitude would be the compound or the group which is anti to the leaving group. It will be bonding with the anti-bonding orbital, and hence the retention of configuration takes place. Okay, so next point is retention of configuration takes place in this reaction. Okay, and bond formation and bond breaking takes place at the same time. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing some more examples of this concept. Okay, till then, good luck and goodbye.